Hello everyone. Welcome back to this YouTube channel. Today we are looking at the inverse of a matrix. But before, kindly like, subscribe, share, comment on the video. It will help us to build the channel. So today we are looking at the inverse of a matrix, and we are looking at 3 by 3 matrix here today. And we'll dig in directly to how to solve the inverse of a matrix. And given the matrix A, so we have the matrix A, which is given by 1 minus 3, 1. We have 2, 1 minus 2. We have minus 4, 2, 3. So we have this matrix A, and you are told to get the inverse. So determine, you are told to determine A inverse. Now for us to get the inverse of a matrix, so A inverse is given by 1 divided by the determinant of matrix A. You multiply this by the transpose of the adjoint of the matrix A. So we have 1 divided by the determinant of the matrix A multiplied by the transpose of the adjoint of the matrix A. So we are going to proceed and look for the determinant of matrix A, then we look for the adjoint of the matrix also, then multiply them together, and we'll have calculated the inverse of the matrix A. So first things first, the determinant. And for determinant, we remember our signage, plus, minus, plus. Then we pick 1, so we have 1, which is a positive 1. We close the row and the column that contains 1. We remain with 1, minus 2, 2, 3, 1 minus 2, 2, 3. Then the next one is a minus 3. Remember the sign is minus, so minus, then minus 3. We close the row and the column that contains that. We remain with a 2 minus 2, minus 4, 3, minus 4, 3. Then lastly, the sign is a positive, so we have plus 1. We close the row and the column that contains 1. We remain with a 2, 1, minus 4, 2. We solve this further, we'll have 1 into 3 times 1, which is 3 times 1, which is 3. So we have here 3. Then minus 4. Then minus 3 will be a plus 3 into 3 times 2, which is 6, minus 8. Then plus 1 into 2 times 2, which is 4, minus 4. Minus 4. And we'll have here 1 times 4 minus 3 minus 4 is a 7. Then plus 3 times 6 minus 8 is a minus 2. Then we have plus 1 times 4 minus 4 is a 8. So we have 7 plus minus 6 and then plus 8. 7 plus minus 6 plus 8. And 7 plus minus 6 is a 1. 1 plus 8 will give us 9. So we have the determinant here being equal to 9. Now having gotten the determinant, let us proceed now and get the adjoint of the matrix. I'm going to move this one just a little bit outside there. Then we will have divide this into 2. Now we want to get the adjoint of matrix A, and this is how we do it. Now you remember from our first videos, we said each element of a matrix has a position. So for example, for a matrix A, it has the positions A11, A12, A13, A21, A22, A23, A31, A32, A33, A33. So we want to formulate a new matrix. We are no longer going to call it A, but it's going to be called C, that will have these positions A11, A12, A13, all through to A33. And we will form this matrix from the matrix A, and it's going to be our the adjoint of that matrix. So we need to find these elements A11 through to A13. Now, the signage also is here is very important. So we are going to have a plus, minus, plus, minus, plus, minus, plus, minus, plus. So those are our signage. Then we proceed now and have the first element, which is A11. We go to our signage, it is a plus, so we have plus. Then we move to our matrix A, and we close the row and the column that contains 1, or the element in A11. When we close this row and the column, we remain with the value. We probably could write the entire matrix here so that it becomes even more clearer. So we have the matrix 1 minus 3, 1. We have 2, 1 minus 2, and we have minus 4, 2, and 3. And now we are saying, let us close the row and the column that contains the element A11, and the A11 is 1 here. So we close the row and the column, and we can see clearly that we remain with a smaller matrix here, which is 1 minus 2, 2, and 3. Now, out of this matrix, we get the determinant. So we'll say 1 times 3, which is 1 times 3, then minus 2 times minus 2, which will give us 3 minus 4, and this gives us a 7. And then we go back to our sign, it was positive, so anything times a positive will remain to be a 7. So our element in A11 is going to be 7. And we are going to repeat this for the others. So we go to the second element, which is A12. So for A12, the sign is negative, so we have a negative. Then we bring back our matrix again, which is 1 minus 3, 1, 2, 1, minus 2. We have minus 4, 2, 3. Now, because we are dealing with the element in A12, we are going to close the row and the column that has the element A12, which is minus 3. So we close this row and we close this column. We remain with a smaller matrix here, which is 2, minus 2, 4, and 3. And we calculate the determinant. Remember now, in this case, we are not picking 3 like the one we did here for the determinants. So we just pick these values here and we multiply them together. So we have a 3 times 2. So we have 3 times 2 minus 4 times minus 2. So we have minus 4 times minus 2. This gives us a 6 minus, this gives us a 6 minus 8, which is a minus 2. But the sign here is minus, so we'll multiply here by minus 1. And this will give us a positive 2. So this is the element that is going to be formed in A12. So again, we move this up to that point. so that we can still maintain our matrix. And we move to now A13. So A13, the sign, remember we had said we have a plus, minus, plus, minus, plus, minus all through. So for the sign for A13, the sign is here, which is a positive. So we'll have here positive. So we say positive here. So we have a plus. We bring our matrix, which is 1, minus 3, 1, 2, 1, minus 2, minus 4, 2, 3. We are dealing with the element in A13, so 13 is this element here, and we are going to close the row and the column that contains this element 1. So we close this row, we close this column, we remain with this smaller matrix here, and we calculate the determinant so that we have 2 times 2, which is 4, minus 4 times 1, which is minus 4. So 4 minus minus 4 is 8, and the sign is positive, so 8 times a positive will remain to be the same. So we have this element 8 as the element in A13. We go to the element in A21 now, because we are done with 1, 1, 1, 2, and 1, 3. So we go to the element in A21. So for element in A21, we have the sign as negative. So we have negative. We bring the matrix. We have 1, minus 3, 1. We have 2, 1, minus 2. We have minus 4, 2, and 3. Now, we close the row and the column that contains the element in A12. A12 is this one here. So when we close this row and we close this column, we remain with this matrix here that is going to have minus 3, 1, 2, and 3. And we multiply 3 times 3, so minus 3 times 3 is minus 9. Then minus 2 times 1 is a 2. So we have minus 9 minus 2 will give us a minus 11. So we have minus 11. And the sign here is negative, so we multiply this by a minus 1 so that we have our answer is a positive 11. And this is the element that is going to be formed in the position A21. Now, moving forward, we have the element in A22. So we have A22. We bring our sign. Our sign for A22 is going to be a positive. So we have a plus. Then our matrix, which is 1, minus 3, 1, 2, 1, minus 2, and minus 4, 2, 3. Again, we close the row and the column that contains the element in A22, which is this one here. So the row and the column, you close it down. Then you remain with 1, 1, minus 4, and 3. So we multiply the diagonals. 1 times 3 is 3, minus 4 times 1 is minus 4. So we have 3 minus 4, which will give us a 7. And when you multiply 7 times a plus, it will remain as it is, which is 7. So that is the element in A22. We proceed to A23. So for A23, the sign is negative, so we have minus. We bring our matrix. Our matrix is 1, minus 3, 1. We have 2, 1, minus 2. Then we have minus 4, 2, 3. So we have minus 4, 2, 3. We again close down the row and the column that has the element 2, 3. So 2, 3 is minus 2 here. So we close this row and the column. We remain with 1, minus 3, minus 4, and 2. So we have 1, minus 3, minus 4, and 2. So 2 times 1 is 2, minus 4 times 3 is 12. So 2 minus 12 should give us minus 10. And the sign is negative, so we multiply this by negative 1. So minus 10 times negative 1 will give us a positive 10. And this is now the value for the element in A23. So we are done with the second row. We move ahead to the third row. So for third row, we have the element A31. So we can have this one moving up, maybe up to that point. So we have the element A31. The sign for A31 is a positive, so we have positive. We'll bring our matrix. We have 1, 3, 1 minus 3, 1. We have 2, 1 minus 2. And we have minus 4, 2, 3. So we close down the row and the column that has the element A31, which is 4. So we close this row, we close this column. We remain with the matrix minus 3, 1, 1 minus 2. Minus 3 times minus 2 is a 6, minus 1 times 1, which is 5. So 6 minus 1 is 5, so we have 5. The sign is a positive, so when you multiply 5 times a positive 1, it will remain 5. So this is the value that we have for A31. So the value for A32, the sign for A32 is a negative, so we have minus. We have our matrix 1, minus 3, 1, 2, 1, minus 2, minus 4, 2, 3. We close the row and the column that contains the element in 3, 2, which is 2. So we close this row. We close this column. We remain with 1, 1, 2, minus 2. And 2 times minus 2 is minus 2. Minus 2 times 1 is 2. So minus 2 is minus 4. And minus 4, we have the sign here is as negative. So we multiply by a negative 1 so that we have a positive 4. And this is the value that we are going to have for the element in A32. Lastly, we have the element in A33, where our sign there is positive. So we have positive, and then we have our matrix 1, minus 3, 1, 2, 1, 2, 2, 1, minus 2. We have minus 4, 2, 3. We close down the element in A33, which is 3. So we close this row, we close this column. We remain with 1, minus 3, 2, 1. So 1 times 1 is 1, minus 3 times minus 2 is minus 6. So 1 minus minus 6, which will give us a positive, will give us a positive 7. So the element in A33 is going to be a positive 7. So that now our C, our matrix C, is going to be formed by all these elements that we got. Now the element in A11, you remember A11 is 7, A12 is 2, A13 is 8, A21 is 11, A22 is 7, A23 is 10, A31 is 5, A32 is 4, A33 is 7. So we are going to write it here in form of a matrix. so that we have now the elements as 7, 2, 8. Then we have 11, 7, 10, 5, 4, and 7. This is our new matrix C. Remember, in our formula, we had said for us to get this, for us to get the inverse, we need to get 1 all over determinant. Already we have the determinant as 9 and CT. And because we already have our C now, we need to get the transpose of this matrix C, which is the adjoint of A, so that it becomes the CT. So for CT is going to be equal to, we get the transpose of this. You remember we said you interchange the rows and the column. So we'll have 7, 2, 8. We have 11, 7, 10. And lastly, we have 5, 4, 7. 5, 4, 7. This becomes the CT. So that now our transpose, our inverse, the inverse of this matrix is now going to be equal to, we said A inverse is going to be equal to 1 all over determinant multiplied by CT. Our determinant was 9. Therefore, we'll have 1 all over 9 multiplied by 7, 11, 5, 2, 7, 4, 8, 10, 7. So you can leave your answer at that, or you multiply every term by 1 over 9, so that we have our answer being 7 over 9, 11 all over 9, 5 all over 9, 2 all over 9, 7 all over 9, 4 all over 9, 8 all over 9, 10 all over 9, 7 all over 9 as the inverse for the matrix A. So this is A inverse, is that matrix which is written there. Now, that is how we go about getting the inverse of a matrix. I'll just run through very fast again. We have the matrix you've been given there. We've said for you to get the determinant, the inverse, you get the determinant, which is 1 all over the determinant times the CT. Calculate the determinant. After you have your determinant, then you need to get the adjoint of the matrix, which you are saying that you need to get a new matrix C, and it is defined by these position elements A11 all through to A13. Get the elements A11 to 31 by having closing down the rows and the columns all through and getting their determinants, and also multiplying by the position signage here, which is plus, minus, plus, minus, plus all through to plus. And then these numbers, the values that you get, which is a 7, 2, 8, 10, 11, 7, 5, you arrange them so that you have them in a new matrix we are calling C. Get the transpose of that matrix, then multiply the transpose by 1 all over the determinant, and you will have your answer as the inverse of that matrix. So up to that point, I can leave you with one question, which you can determine the inverse. I'll give you the question and the answer, then you can identify if you can be able to get the determinant of that question. So we have a matrix B defined by 1, 1, minus 1, minus 2, 1, 1, 1, minus 1, 2. So we have this matrix, and you are told to determine the determine the inverse of B, the inverse of B, or B inverse. The solution of this matrix will be like this. So you'll have 1 divided by 7 of 3 minus 1, 2, 5, 3, 1, 5, 3, 1, 1, 2, 3. So if you want to know how we get that solution for that question, you can look out for the next video where we'll be solving simultaneous equations using inverse matrix method, and we are going to be solving this question as we solve a simultaneous equation. Otherwise, thank you very much for watching up to the end. Take time and calculate the inverse of that matrix B, and we meet again in the next video. Subscribe, like, give us feedback, and we are really going to appreciate. Otherwise, up to that point, bye bye.